Hello friends, welcome to my channel. This is Fluid Mechanics Isro question paper from 2006 to 2016. This is part 5. Question is, the tank shown in the figure below is closed at top and contains air at a pressure of PA. The value of PA for the manometer reading shown will be how much? Here pressure PA we have to calculate. So this one is mercury, here water, oil and air. So this height we will calculate here. It's 200 minus 150 plus 10. So it's 60 cm, this height, water column height. So we will balance at XXA. So this is Hg here. So rho g Hg into height is 10 cm, so 0.1 meter into PA plus here PA, then oil rho g, left side right side we will balance. Here this is left side and from here we will start right side, this one. Right side PA plus rho g oil into H oil is 150 cm, so it's 1.5 plus rho g water and H is we already calculated 60 cm, so it's 0.6 meter. This one we have to solve. Here we will put the values. Density of Hg is 13.6 into 10 to the power 3 into 9.8 plus 0.1 is the height, equal to PA plus rho g oil. Oil is given 0.75, so it's 0.75 into 10 to the power 3 is the density. This one, it's density. G 9.8 into height 1.5 plus rho g water 10 to the power 3 into 9.8 into 0.6 is the height of water column. So we have to calculate PA. So PA equal to, take 9.8 common, 10 to the power 3 into 9.8, 10 to the power 3 into 9.8, so it will come 13.6 into 0.1 minus 0.75 into 1.5 minus 0.6. So 10 to the power 3 into 9.8, 13.6 into 0.1 into this will calculate separately. Here it's 1.36 minus this one, here I did 0.75 into 1.5 is 1.125 plus 0.6, so minus 725. It will come 10 to the power 3 into 9.8 into minus 0.665. So it will come 10 to the power 3 into minus 6.65, nearly 10, 9.8 you can take, nearly 10. So options are in kilopascal, so minus 6.65 kPa. From option we have to check minus 6.65, nearly C. So C is our answer. Question is, a rigid body is rotating with constant angular velocity omega about a fixed axis. If v is the velocity of a point of the body, then curl v equal to how much? We know omega is the constant angular velocity. So this we can call it a rotation. We know rotation is half cross product curl of v, del cross v, or we can write half ijk del by del x del by del y del by del z u v w. So in this question, del cross v equal to 2 omega. Del cross v is curl of v. Curl of v equal to 2 omega. This is our answer. So from option C is our answer. Match list 1 measuring devices with list 2 measuring parameter and select the correct answer using the codes given below the list. List 1 device, A is pitot tube, this is very important. Then B micromanometer, C pipe bend meter, D wall pressure tap. Then list 2 parameter, one is flow static pressure, second is rate of flow indirect, 3 is differential pressure, 4 is flow stagnation pressure. A, B, C, D. A is pitot tube measures stagnation pressure. This is very important. Then micromanometer, B, it's 3. Differential manometer. Then C, pipe bend meter, it indicates rate of flow. Indirectly we can measure rate of flow. So C is 2. Then D is 1. Flow static pressure. Wall pressure tap measures flow static pressure. So answer is 4, 3, 2, 1. So B is our answer. From here also we can do one thing. Pitot tube measures flow stagnation pressure. So one is A is 4. So you can cut A and C. After that you go for B and D. From there you have to check other options, whether which one is matching, which one is not matching. Next question. The general equation of continuity for 3-dimensional flow of a compressible fluid for steady flow U, V, W are components of velocity in x, y and z direction respectively. This one already discussed in my previous video, you can check it. So general equation of continuity flow for a compressible fluid and steady fluid. So time term will 0 and compressible fluid rho will 0. So del u by del x plus del v by del y plus del w by del z equal to 0. A is our answer. 3-dimensional flow continuity equation for steady and compressible fluids. In centrifugal pumps, maximum efficiency is obtained when blades are. This is also a very famous question. So many times asked in IAS. Bend backward is its answer for maximum efficiency. I will draw how the blades will here. If it is rotating in this direction, then blades they will bend in this direction. And for bent forward, if it is moving in this direction, the blade will like this. This will generate maximum pressure. This is for maximum efficiency and this is for maximum pressure. Bend forward, bend forward and bent backward. If the characteristics of a pump are shown in figure, what is represented by abscissa? This is discharge Q. Or Q. In pump, discharge is important. When discharge increases, head is decreases, and when discharge increases, BHP is slowly increases. And for efficiency, when discharge increases, efficiency increases, and after a certain point, efficiency will decreases. This is efficiency. This is for head. This is BHP, brake horsepower or power. This curve also very important for IAS examination. So many times they will ask characteristic curve of pump. Head versus discharge, how it will behave, or efficiency versus discharge, or BHP versus or power versus discharge in case of pump. So all three are important. A rocket exhausts gases with rho equal to 0.5 kg per meter cube out a 50 cm diameter nozzle at a velocity of 1200 meter per second. The thrust we have to calculate in case of a nozzle. So data given are rho is density, kg per meter cube, diameter of nozzle d equal to 50 cm, so it's 0.5 meter, and velocity v equal to 1200 meter per second. We have to calculate thrust or force. Thrust or force. F equal to m dot into v1 minus v2, rate of change of linear momentum. And area for m dot we have to calculate the area. Area is pi by 4 d square, so it's pi by 4 into d 0.5 square. Then force F equal to rho A V, m dot is rho A V into V2 is 0, V1 is V. So rho A V square. Then put the values. Rho is 0.5 or 1 by 2, 0.5 into area is 5 by 4 into 0.5 square into V square. Velocity is 1200. So it's 1200 into 1200. 0.5 is 5 by 10 into 5 by 4 into 5 by 10 into 5 by 10 into 1200 into 1200. 1, 2, 3. So 4 into 12, it's 3. Finally 125 into pi into 120. This is in Newton. Options are in kilonewton, so divided by 1000. It's 8, then it's 15. So 15 pi kilonewton. 15 into pi. Here 1 3. Here 45 into pi. Pi value is 3.141. If you multiply 45 into pi, it's 45 into 3 is 135. So nearly approximately C is our answer. 140 kilonewton. Which of the following pairs of velocity components u and v satisfy the continuity equation for a two-dimensional flow of an incompressible fluid? Continuity equation and incompressible fluid. So, and it's a two-dimensional flow. Continuity equation in 2D is du by dx plus dv by dy equal to 0. First we will check this one. A will check. Del u by u is 2x square plus 3y cube. So del u by del x, it's 4x. Then del v by del y, it's 9y square. So from here plus del v by del y is not equal to 0, or 4x plus 9y square is not equal to 0. So A not possible. Sorry, v is minus 3xy. So del v by del y is minus 3x, and here minus 3x is x is not equal to 0. Next b, del u by del x. So del by del x of u is 3x minus y. So 3. Then del v by del y. V is 2x plus 3y. 2x plus 3y. It will come 3 only. So del u by del x plus del v by del y equal to 3 plus 3. It's 6, which is not equal to 0. So B also not possible. B also not possible. In option C, u is equal to a sin xy and v equal to minus a sin xy. So del u by del x equal to a is constant. So del sin xy by del xy by del x. Here we will get a cos xy into y, then del v by del y, it's minus a common, then del y del xy sin xy into del xy by del y. So from here we will get minus a cos xy into x, del y cancel 1. So del u by del x plus del v by del y equal to a cos xy into y minus a cos xy into x. So this is not equal to 0. So C also not possible. So finally D option only left. So D is our answer. We can check this one. D, u is cx, v is minus cy, del u by del x is c, del v by del y is minus c, then del u by del x plus del v by del y, continuity equation in two different, c minus c equal to 0, which satisfies our continuity equation. So D is our answer. And we can check this for incompressible flow also. For incompressible flow, del dot v equal to 0. This one also we can check. How you can check? This one already discussed in my previous video. The flow of a fluid in a pipe takes place from its higher energy level to lower energy level. V1 square by 2g. Bernoulli's equation we will write here. Z1 equal to P2 by rho g, V2 square by 2g plus Z1 plus loss of head loss. Here at point 1 total energy point 1 is greater than total energy at point 2, and total energy 1 equal to total energy 2 plus head loss. If total energy at 2 is greater than total energy at T2, T1, then head loss will come here. If T2 is greater than T1, then head loss will come this side, left side. P1 by rho g plus V1 square by 2g plus Z1 plus head loss equal to P2 by rho g plus V2 square by 2g plus Z2. So from higher energy to lower energy flow will take place. D is our answer. Thank you friends. Thank you for watching my video. If you like my video, then subscribe it.